All right, let's get a little more complicated here. Let's say you throw a ball up in the air. Okay, if you throw a ball up in the air, you guys know what's going to happen. It's going to go up, 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 stop, and fall back down. Well, in physics, we've determined that the function that a ball thrown in the air follows is this. Y equals my initial y distance. Initial y distance is where I start. Y is where I end up. Plus my initial velocity, we call that v naught. This would be y equals y naught plus v naught. V naught and y naught are my initial position, my initial velocity, times time. So initial velocity times time plus 1/2 times g times t squared. We're going to talk a lot about g the next few chapters, and g is a constant of nature. And in SI units, g is 9.81 meters per second squared. Well, let's say that you wanted to find how long a ball was in the air, knowing all these other variables, knowing my final y, my initial velocity, and g is a constant, and 1/2 is just a number. Well, this is called a quadratic equation, and you will have to know how to do this, but you won't have to do it by hand. I am going to give you a a calculator program that will allow you to find the roots of this equation meaning that t can equal two things. For every variable you're given, because it's a square function, it can equal two different numbers. In other words, if I graph this, it's going to look something like this. And notice that I start here. This is if I throw the ball up and catch it, and I end here. And you'll notice that, let me get a different color here, that the same y variable, y is in meters, and time is in seconds. That's what's down here. So my variables are y and t. You'll notice that for every, there's always two y variables that are the same. In other words, t1 will have the same y variable or some t initial as some t, sorry, it's not a very straight line, as some t final. They'll have the same y value. So in other words, functions like this is called a quadratic or a parabola, will always have two answers that will satisfy this equation. Well, it's called the quadratic equation, and the people have already figured that out, and so I'm going to give you a calculator program that will give you the roots of the equation. You'll need to know how to do that and what it means. So we'll talk about that when we get there. The other thing I want to talk about is triangles. We're going to use triangles, and it's probably going to be some of the most difficult math that we'll do in here, plus or minus. But let's take a triangle here. Let's see, here's some shapes. Let's see if I can make a triangle. Yeah, so let's just take a triangle. Triangle, you already know, has three sides. We call this side here the hypotenuse. I'll just make H for it, for hypotenuse. A, B, and C is what a lot of people do. They'll say A, side B. Side C is always the hypotenuse. So the hypotenuse is the longest side of a triangle. There are always three angles. This particular triangle is called a 90-degree or right triangle because it has one 90-degree angle in it. If you add all three of these angles together, you always get 180 degrees, always. So I'm just going to pick one of these other, not the two that are not 90 degrees. I'm going to pick this one right here just because I get to pick whichever one I want, and I'm going to pick this one. So if I pick this one right here, this angle, that is the Greek letter theta. Theta is just a Greek letter we use to represent angles. And so this angle here is theta. And so there are some functions that the Greeks figured out. And you know, probably the Egyptians did, but the Greeks wrote it down so they get to claim that they knew it first. And that is sine theta, cosine theta, and tan theta. This is pronounced sine, not sin. Sine, cosine, tan. And here's what they mean. Sine is always opposite leg over hypotenuse. Okay, in this case, that would be A divided by C. So these are just ratios. These are just numbers. Turns out that a triangle always a 90-degree triangle always works this way. Cosine is adjacent, the adjacent side divided by the hypotenuse. Now when I'm putting opposite hypotenuse and adjacent hypotenuse, I mean the actual length. If I took a ruler and measured the length of this hypotenuse, it would have a certain length, and it would be the longest length of the three sides. I could measure A and B, and they would be a certain length. All right. So in this case, adjacent would be the side B divided by the hypotenuse, which is side C. Now tangent, which I'm going to move down a little bit so I have more room, tan theta is equal to opposite divided by adjacent. Now again, when I'm talking about this, I'm talking about the actual length of the sides. And so that's going to be A, whatever the length of that side is, divided by B. And so most people there's a little acronym that math people use, and it's SOHCAHTOA. TOA. And it just helps you remember sine is, you know, you really don't have to have that. If you use this enough or you just work with it enough, you just know it. You just know it. Now, so if this is a 45-degree angle, and I know one other side, I can find the other side. And so if I just have two measurements on here, I can find all the other ones using these functions here. Now something else that, let me go down a little bit here. All right, so let me go down, yeah. Something else that is important to know is I can know the sides and find the angle. So let's just say, let's make up some numbers here. Let's say A, B, and C. Let's say this is a 3, 4, 5. And let's just say these are centimeters, all right? Centimeters is not SI, it's not SI, but it is part of the SI system. SI is actually meters. And so let's say that I wanted to know this angle right here that we were looking at. Let's go back up and look at it. So I got sides A, B, and C. I know the size or the length of A, B, and C, and I want to know about these angles here. Well, the way you do that is you're going to say sine of the unknown angle, I don't know it, would be equal to opposite. Well, what's opposite? If I go back up here, opposite is A. Well, what's A? A is 3 centimeters divided by, what's C? That's hypotenuse, because remember it's opposite over hypotenuse. That's going to be 5 centimeters. Now, on your calculator, there is actually a button that has sine on it. Well, if you look right above sine, there's this symbol that is in either blue or orange, and it's sine to the -1. And so what we want to do here is we want to do inverse sine. That's what this really means. It means inverse sine. And if I do inverse sine, it's going to give me the angle. So theta is going to equal sine to the -1, and this is what you're going to put in your calculators. Sine to the -1. So second sine, parentheses, 3 divided by 5. I don't have any units because the centimeters divide out. And that's going to give me a number. Now you got to be sure you're in degree mode, which I'll show you how to do that when you get in class. But if you do second sine of 3 divided by 5, you get 36.9 degrees. So this is going to be 36.9 degrees. So I know this is 36.9. Well, I could also find this one. I could find that one by adding 90 plus 36.9 and subtracting from 180. I could do that. Or I could just find this one by using sine. And in this case, if I'm using this, the opposite's going to be B. See, that's for this. Let's make this red. How about that? So we can tell the difference. There's red and black here. So for my red theta, which is this angle, this is the opposite now. And this is the hypotenuse hadn't changed. The hypotenuse hadn't changed. So in this case, it would be sine theta equals 4 divided by 5. That's opposite over hypotenuse, right? So if I put it in my calculator, theta, that angle, would equal sine to the negative 1 of 4 divided by 5. Centimeters are going to divide out. It's just going to give me a number. So I'm going to do the same thing, except I'm going to put 4 where 3 was, and that's going to give me 53.1. I'm rounding off to what we call 3 significant figures here. We could put a lot more numbers in, but we're actually using measurements, and you really 2 or 3 significant digits is all you ever need. Never ever put all the numbers in your calculator. So, and then I know this is 90. This one we of course know is already 90 degrees. That one's given because it's a right triangle. So you need to study over this. We'll use this a lot in the 3rd chapter of the book. And it'll be helpful if you know that. So that's some of the hardest math we'll do, and this will be a good review before we actually start class.